It's totally unstable. It's going to explode. No giving me will not be an amazing and open door to go for that. The thing is, it might be tomorrow. It might be during this transmission. What's more, it would glimmer like a subsequent sun over the James Webb Telescope. Actually, it has perceived an amazing 250% development in the magnificence of the red star found at the shoulder of the Orion group of stars. This fanciful way of behaving has ignited energy for a dazzling highlight. Some suggest the unexpected extension in magnificence could show that Betelgeuse is wanting to go supernova. However, the exact timing remains problematic. Experts check it could occur after a short time. Join us as we examine the depths of space and unravel the secrets surrounding this great, giant bug. Betelgeuse has the potential to reshape how we comprehend the universe. No matter what its name, not being well known, you've probably taken note of its magnificence. A stunning, blushing sparkle shining at the shoulder of Orion, a perceptible star group. Betelgeuse's size is wavering. Whenever set at the middle of our planetary system, its outer surface would reach out beyond Jupiter's orbit. This monster star, easily apparent, continues to enchant us. Unlike most stars, Betelgeuse shifts in magnificence over time due to its area to our system, known as a semi-regular variable star. Its quality changes infrequently, demonstrating a potential devastating breakdown in a vast explosion. As of recently, Betelgeuse has become fundamentally more astonishing because of shocking changes in brilliance. These changes include a huge flood on May 20, 2023, when scientists observed a baffling 142% addition in magnificence, followed by a later update showing a 150% development. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, noticed that Betelgeuse currently ranks as the 7th most brilliant star in the night sky, climbing 3 spots from its typical 10th spot. From the southern hemisphere, Betelgeuse sparkles brightly in the night sky, easily visible at the shoulder of the Orion star grouping. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, underlines Betelgeuse's importance. It offers an enamoring chance to study the final phase of a huge star's life, providing critical insights into the behavior of red giants before they explode as supernovae. When Betelgeuse ultimately explodes, it could turn out to be extraordinarily brilliant for around 7 days, potentially casting shadows at night. This prospect has both amateur stargazers and expert astronomers eagerly anticipating the event. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Space Researchers and Cosmology Club, highlights the enduring interest in Betelgeuse's brightness changes, a phenomenon long neglected by other societies. Currently, Betelgeuse's brilliance cycle lasts around 130 days, much shorter than its typical 400-day cycle. These quick changes offer stargazers a unique opportunity to study this heavenly phenomenon in detail, revealing more about the final stages of a star's life. The peculiar behavior of Betelgeuse began in 2019, when it violently ejected part of its outer environment. These changes in brilliance are extraordinary for Betelgeuse, igniting speculation about whether it will soon detonate into a supernova. According to a paper by Dupree and other specialists from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its usual 400-day brightness cycle. Despite its unpredictable behavior, Betelgeuse remains a gigantic red supergiant star going through the final phases of rapid development as it exhausts its fuel. The center will eventually break down under its massive mass, resulting in a giant explosion that might potentially obscure whole galaxies. The timing of this explosion remains uncertain, as explained by Dr. Doc, a professor of space science at the University of Portsmouth. Predicting galactic explosion events is challenging due to limited historical data and the complexity of heavenly development. Betelgeuse is currently undergoing fusion processes, continually evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon at its core, a process that takes years. Eventually, it will progress to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and potentially forming a black hole or neutron star. While some speculate about Betelgeuse's approaching explosion, Historical records show that it has been growing redder over the past few years, suggesting it might take considerable time before it goes supernova. NASA estimates that Betelgeuse is not expected to detonate for another 100,000 years, offering comfort that its impact is unlikely to occur within our lifetimes. Nevertheless, the uncertainties in Betelgeuse's behavior continue to captivate researchers and inspire progress in our understanding of heavenly development. Dr. Sarah Webb reminds us to remain open to all possibilities, even as we recognize that the likelihood of seeing Betelgeuse's explosion in our lifetimes is slim. Following its changes could lead to further scientific breakthroughs, allowing us to maintain hope for new discoveries in the universe. It is important to remember that our observations of Betelgeuse are essentially windows into the past. The light we see from the star is over 600 years old, meaning Betelgeuse might have already detonated, and we wouldn't yet know it. While this possibility exists, it remains uncertain. History has shown that our assumptions in astronomy can be challenged. Before 1987, astronomers believed that only red supergiants could go supernova. However, in that year, a massive blue star in another galaxy exploded, stunning the academic community. There is still much to learn, and surprises might lie ahead. Noticing Betelgeuse and other massive stars allows us to expand our understanding of heavenly phenomena. Regardless of the lack of an imminent explosion, Betelgeuse's ongoing behavior remains fascinating. Its changes, both diminishing and brightening, uncover captivating physics. The fact that stars evolve on human timescales is remarkable. While Betelgeuse is currently much brighter than anticipated due to its unpredictable multi-day cycle, there is hope it will eventually return to this cycle. However, later observations suggest that Betelgeuse might be in its the last stages are switching up the finish of its center carbon-consuming cycle. This stage includes the change of carbon into heavier components, like oxygen and magnesium. Provided that this is true, specialists expect a core breakdown, prompting a cosmic explosion that could occur within a couple of years. In any case, the specific phase of Betelgeuse's development remains challenging to determine, and uncertainties persist. The chance of seeing Betelgeuse's blast remains hazy, as the carbon-consuming stage can endure for up to 1,000 years. Moreover, the study suggesting a looming influence has yet to be acknowledged for publication. Nevertheless, the potential for Betelgeuse to turn into a cosmic explosion is invigorating. It would be an interesting event visible in any case, even during the day, for several days. When the blast finally happens, the early indications of the heavenly blast will be subtle but obvious, with neutrinos clearing across Earth as high-energy photons escape from the growing haze of grandiose garbage. Betelgeuse will gradually grow brighter in the night sky, perhaps reaching a peak brightness 10,000 to multiple times its usual brilliance within weeks. This event will astound anyone fortunate enough to observe it, marking a significant moment in cosmic history. The remnants of Betelgeuse's blast could be as bright as a quarter or half of a full moon, packed into a single point of light. Surprisingly, this brilliance would be visible during the daytime, casting dramatic shadows at night. Estimates suggest that Betelgeuse could become 15 to 20 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's blast would last for at least 100 days, dazzling space enthusiasts and offering an extraordinary opportunity to observe the repercussions up close. Luckily, Betelgeuse's cosmic explosion would pose no threat to mankind, as it is still far away. Telescopes and optical instruments would allow us to observe the event without harm. Nevertheless, such a tremendous occurrence wouldn't go unnoticed. Supernovae are often interpreted as foreboding signs, and Betelgeuse's downfall could incite interesting responses. Most astronomers believe it could certainly reignite worldwide interest in stargazing, arousing people to the wonders of the universe. Betelgeuse doesn't appear to be the only red supergiant in our galaxy. Others like Edi Carni could explode before it does. In fact, our Milky Way should experience a cosmic explosion about once every 100 years, though we haven't seen one in the last 400 years. However, we have noticed the remnants of past explosions, demonstrating that we're overdue for a major cosmic event. It's just a matter of time before the next star goes supernova, and the universe will pay heed. Betelgeuse's history is rich with notable events, including the dramatic dimming in the fall of 2019, This sudden drop in brightness confused cosmologists and sparked speculation about its possible explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations provided insights into the phenomenon. Skywatchers can easily detect scarab juice from their homes, making it an accessible cosmic object to engage with. If a cosmic explosion happens, it would undoubtedly provide a fantastic celestial display. As we continue to monitor Betelgeuse, the star remains a focal point of interest for both professional astronomers and amateur skywatchers alike. The ongoing changes in its brightness offer captivating opportunities to study the cycles occurring within a dying star. With cutting-edge technology, scientists can now observe Betelgeuse's behavior with remarkable accuracy. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are uncovering more secrets about this cosmic giant. The study of supernovae like the one Betelgeuse may eventually become has far-reaching implications beyond understanding the final stages of a star's life. These explosions play a vital role in the creation of elements heavier than iron, which are essential for the formation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the building blocks of the universe, allowing new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova during our lifetime, it would provide an extraordinary and awe-inspiring opportunity to witness such an event up close. For those fortunate enough to observe it, it would be a once-in-a-lifetime spectacle. The light from the explosion would temporarily outshine all other stars, becoming a prominent feature in our sky as space specialists race to capture data. The event would fuel further advancements in space exploration, enabling more research into stellar evolution, supernovae, and the mysteries of the universe. Regardless of when it happens, Betelgeuse's potential explosion will be a critical event for cosmology, expanding our understanding of star death and the life cycles of massive stars. The display may also inspire future generations of cosmologists, sparking an interest in the universe and encouraging people to gaze in awe at the vastness of space. As scientists continue to observe Betelgeuse's behavior, the mysteries surrounding its life cycle and impending explosion continue to spark interest among mainstream researchers. One of the most fascinating aspects of this star is its unpredictability. While many stars exhibit regular patterns of brightness, Betelgeuse is anything but typical. The changes in its light output are not only due to its natural variation, but also the violent activity occurring in its outer layers. These eruptions, which expel material from the star's surface, are signs of its instability and add an extra layer of complexity to its potential to become a supernova.